In this video, I want to talk about generating quality soil scans. Now, there's two purposes why you might want to be scanning soils today. The first is you're trying to generate a calibration or training data set with which to create soil carbon prediction or classification models to be used at a later date. And the second is to scan your soils and generate actual predictions or classifications based on calibration models that have already been created. So in that first case, that you're generating a calibration data set, there's a couple of key considerations. First is soil moisture. Moist soil will significantly affect the reflectance spectra of your soil. So you really want to make sure that the soil has been air dried or dried, like if using like a drying oven or something else at low temperature. You don't want the temperature to be too high that it's actually burning off some of the organic matter in the soil. So make sure it's dry. You want to make sure that the soil has been well sieved and homogenized. Some would suggest grinding the soil. I do not suggest grinding the soil, and the reason is if the goal is to generate a calibration data set for later deployment in the field, if you can't grind the soil in the field, then generating a training data set using ground soils is not going to give you a good prediction model to be deployed in the field, right? So in the field, at best, people are going to be able to use a sieve or a colander or something else to quickly homogenize and break up the soil clods. So you should only be using the same thing or something similar when generating your calibration data set. So key things to consider. Now, if you're in the field or you're planning to be in the field and you want to get soil scans and generate predictions, that soil moisture is still really important. If you're lucky enough to be in one of the parts of the world that has a distinct dry season, and by lucky, I mean that it's really easy to time when you go out to the field to ensure that the soil is dry, that's great. Time your sampling at periods where you know the soil will be dry, and then you can collect soil, sieve it, and scan it very quickly. If you're not able to sample during a distinct dry season when the soil might be moist, the best thing to do is bring something like a black plastic sheet with you. So you collect your soil, homogenize it, take a small subsample to fill your soil dish, right? This is a pretty small dish, so you don't need a lot of soil. Then spread that out on a black plastic sheet, like a garbage bag, thinly, and within 5 to 20 minutes, depending on how bright or intense the sun is, you should have a dry soil that you can scan. The other thing to consider in the field is the sampling depth. You want to, as best as possible, match the sampling depth that was used for your calibration training data set. So if the training data set was using soils that were 0 to 10 centimeters deep, and you're sampling in the field 0 to 20 centimeters deep, that might cause an inconsistency and your model predictions may not be as accurate as you would like. So as best as possible, match those two. That's not always going to be possible. Now, for the actual collecting of a soil scan, if you're in the field, you've collected your sample, you've ensured that it's dry, you want to make sure that you've removed any big chunks of organic matter, any stones, and then you've homogenized the soil. You want to make sure that your soil cup is filled at least halfway, because you want all of the light from the reflectometer, all of the light that's coming from here, to either get absorbed by the soil or reflected back to the sensor. So if your soil is too thin in the dish and soil and light can pass through, that is going to negatively impact your measurements. The other thing to be aware of is how consistent the soil, you can't really see here, but when you look at the bottom of the cuvette, do you see a pretty consistent matrix of soil? Or do you see, for example, large clay aggregates, and then you can see like these hollow gaps. That will also influence your measurement as well. So wherever possible, maybe you can tap the soil a little bit, try to maybe remove some of the big aggregate, try to kind of break it up a little bit so it's better homogenized, and then put it back in the soil dish so you have a nice consistent kind of matrix at the bottom. Then when you put it on on the reflectometer, you want to make sure, just turning my device on because it's going to need to be. So you can use this little hook here to keep the clamp open. If that breaks, you have to hold it open. But you want to make sure that you're covering all of the optics with the dish. You don't want it to be half off so that, again, light can escape anywhere other than hitting the soil. So you want to load that up. I'm going to set this on the table so it's nice and stable. And I'm going to take some soil measurements. So if you are doing a calibration data set, you definitely want to scan 3 times, in which case you want to, after every scan, you want to turn the dish a little bit. So you're continuing to scan different portions of the soil. If you're in the field, your survey may only have 1 space for a scan, or even if there's spaces in the survey for 3 scans, I'm going to turn the dish again for this last scan. Or there may be 3 spaces for scans, but you only need to do 1. So that's really up to people's discretion. But if you are taking multiple scans, make sure you turn that dish after each scan, just to ensure that you are measuring every part of the soil. If you are running a prediction model in the field, instead of this done measurement that you see here, this done screen that you see here, you would probably see something like run calibration, predict soil carbon, classify soil carbon, or something to that effect at this point, in which those values from the reflectance measurements would be fed into the model and you would get an output in real time. Thank you.